Okay, we'll get started with this live stream in just a few moments. Just tweaking some settings. If you're watching along, please say something in the chat so I know there's somebody here. Okay, so the agenda for today is going to work, but I'm going to go through a quick demo and explain how LoRa to LoRa using raw LoRa works. Then I'll probably do some questions at the end as well to take any comments, feedback, some input on how the stream was, because it'd be interesting to see whether it was worth it doing in this format or whether we should try another format. Okay, fantastic talk. That's good to hear that it's actually streaming okay. Right, we'll kick off in that case then. So one of the concerns that we've been seeing in the forum recently has been some questions to do with how raw LoRa to LoRa works. And actually, we've noticed there has been a slight error in the way that the documentation was presenting the demo code for the LoRa to LoRa. So the way that it should work is that if you create a LoRa object, as you can see on my screen here, I've got this chunk highlighted. It should create a LoRa object instantiated with a couple of default parameters. Currently what was happening was that it wasn't receiving the expected spread factor. So Daniel's now working on this and should push a firmware update, hopefully either tonight or tomorrow. So this will correct it, meaning that anything that's instantiated with no parameters should create a successful LoRa object. So I'm going to walk through my code. I think a lot of people who were experiencing this problem had concerns about why it just wasn't working. They understood the functionality, but I'm going to go from the top down to make sure anyone who wants to understand about it can understand a little bit more. So from the top, we're starting with importing our LoRa library. So from network, we're importing LoRa. This is the class that we want to generate all of our LoRa packet data from. So this manages all of the LoRa connections and makes it simple for us not to have to worry about anything. Then we're grabbing the socket class. So this manages the connection from end to end, manages our packets, and allows us to send data backwards and forwards over LoRa. We're then importing machine, which I don't think we're actually using here. I had an example where we were just turning some GPIO pins off and on, so that's actually not necessary. You don't need that in your example. Oh, actually, no, we do use it. We are sleeping at the end, aren't we? So we're using that to generate some random time intervals to sleep the device for in between receiving and sending data. And then we're also grabbing time, which we're using to, as I said earlier, sleep the device in between receiving and sending data. So to start off, what you need to do is you need to instantiate a LoRa object, and this is generated from the LoRa library we imported earlier. So from network, import LoRa, and then from LoRa, we want to create an LoRa object based around the LoRa library. So just calling our object LoRa, set that equal to the LoRa class, instantiating it in mode LoRa LoRa. This means we want to use raw LoRa. If we wanted to use LoRaWAN, you could do mode equals LoRa.LoRaWAN, and that would set up the class in such a way that you're expecting to do either over-the-air activation or activation by personalization. I'm probably going to follow up this tutorial with one next week looking at nano gateways and doing TTN connections. So we'll look more about LoRaWAN next week, or rather the week after even. But one of the issues we were having with the library was that it wasn't instantiating a spread factor, and that turns out to be what was causing a lot of issues and concerns on the forums. So temporarily, you can avoid the problem by actually instantiating your own spread factor and specifying the specific spread factor you wish to use. In this case, we're setting it to 7. You can check the documentation. I believe there's a number of different options for the spread factor. Here we're just using 7. It depends on really your broadcasting circumstances and where you're trying to, or how you're trying to deliver your data. So we'll create the LoRa object in mode LoRa with the spread factor set to 7. Later today, when Daniel pushes update, you shouldn't need to specify that. It should activate by default. Then what we're doing is we are creating an object called S. This is from the socket class. We're going to use this to manage our connection between our sending and receiving devices. So just quickly to show you, we've got here a LoPy. So this is just standard LoPy plugged into an expansion board with the LoRa antenna. I'm based in the UK, so we're using 868 megahertz. If you're in the US, you should probably look at 912 megahertz, I believe is the standard for unlicensed spectrum. And obviously it depends on where specifically you're located as to what the legislation is around frequencies you should be broadcasting on. So after we've instantiated our socket object, we'll then do a quick print statement to know that the device has started up correctly and that we've not had any problems with our boot or our main.py files. Then we'll create a loop. So what we're going to do here is we're just going to send 2 messages back between devices. So I've got 2 devices here. We've got device A and device B. So device A is sending the message hi, and then device B is sending, if this is going to open, oh no, we're in device B already. Okay, so device A is sending hello, and device B is sending hi. So what we should get when we run this is we should have 2 devices in terminal printing out hello and hi backwards and forwards between each other. And this will be entirely over raw LoRa using LoRa Mac. So what we've done here is we created a blocking socket. This is to say that don't execute any other code until we've sent our hi message. After we've sent our hi message, then we can set the blocking socket to false. This is to try and adjust for any of the latency or delay between 2 devices taking longer or shorter periods of time to send between one another. Then with the socket set blocking to false, we'll then receive our data. So what this will do is, in the background, as we continue to execute our code, the LoRa socket is waiting to receive any data. It'll then take this received data, store it to a buffer known as a variable named data, and then print out data if it receives something. So what this will do is sometimes it won't necessarily always print out the data, because obviously if there's a discrepancy between the 2 devices and they're sending over a varying period of time, then the data will come through at different rates. So because the socket's not blocking, this means that we'll go through print data sometimes without actually having received anything yet. So we could set it to blocking and wait until we receive the other one, but it's easier to keep checking by allowing the code to continue to run rather than having to constantly check back in and wait for our code to unblock before we can continue. So, and then we print out our data just to check that we've received anything. And then in the very last line, we're doing a quick sleep, which is taking a random interval and sleeping for a random period of time. This is just to, again, make up for the variation in delays between the 2 devices sending and receiving information. So I'll quickly plug this in and flash the board. So I think this one should already be running the code. So I'll get it up in terminal and show you that it's sitting waiting to receive data. So this is LoPy either A or B. We'll see when we get the terminal up. Let me fire up terminal. Where's that gone? Okay, there we go. So let me just scale that back. Okay, perfect. So that should now be coming through for you. By the way, I'm happy to take questions while I'm going along here, so if you do have any concerns or want to ask something, let me know as I'm going. Otherwise, I might forget what I said and it will be a little bit hard to follow. So just ping a message in the live chat if you want to ask something. So I'm going to quickly jump into the LoPy and see if it's receiving data or if it's working. Okay. So we'll give that a quick restart so that we can see all of the code that's being output. So all I'm doing here is just taking a jumper lead and hitting the reset button from within the case. Okay, so that's sending out its startup information. Okay, so that's device A, so it says starting up A, and then we're receiving an empty packet, which is specified by this B quotation. That just means there's been nothing received on the packet, on the LoRa socket even. So then what we can do is we can take our other LoRa device, which will be LoRa B, and this is going to be sending our alternative message, which is hi, and our LoRa A should be receiving hello. So I'm going to try and work this out because I've now run out of USB ports on my computer, but we should be able to connect up to an external battery pack and be able to send data between the two devices. So because I've run out of USB ports, we won't be able to see the terminal output from the LoRa B device, but what we're going to use here is just going to use a battery pack to plug into and show you how the sending and receiving data takes place. Okay. And turns out that's run out of battery as well. That might make life a little bit difficult. How can we power this? Give me a second. I'll tell you what we do. We'll steal power from the other board and do it that way. So I'm just quickly grabbing the ground and power lines from another board. Should have enough current hopefully to supply both boards, and powering this one. Okay, so we've now got both boards connected, and once the device B starts up, you should be able to see them sending data through between each other. So we've got device B and device A, and they should both be transmitting now. So hopefully we should see our incoming data in a minute, assuming that they're both connected to the Wi-Fi. I'll quickly jump into the other board and see what's happening with the code. Let's just check that this one's working as well. So if you have a look at the terminal, I'm just going to change boards quickly. Okay, so that's sending hello, or even receiving hello. So that's a sign that the board is definitely sending data and receiving data, because what we have in device A says that's sending hello, and device should be printing out what it receives in the data buffer, which is here. So, as I said, sometimes the data buffer doesn't receive anything. This is simply because the socket gets set to not blocking, in which case the data sometimes goes around without receiving anything, as you can see. If you wanted to clean this example up, you could probably set it to blocking to be true, in which case it would wait until it receives something, but we could be here a little while if the devices are out of sync. So that's device B receiving hello, and if we swap back to the other one, and quickly jump into the code for this one, so this is a different serial header. We should hopefully see hi. Yeah, so this is the two boards talking to each other now. So we've got device A sending hello to device B, and device B sending hi to device A. And you can see by the output on the terminals that they're receiving and sending the data. So the example's fairly straightforward. I think the confusion on the forum was to do with the slight instantiation issue that we were having with the class. Daniel's now working on this, so this should be corrected by this evening or tomorrow. And what you should be able to do is if we go back to the Atom editor we've got up here, you should just be able to instantiate your class with the default parameters by doing LoRa equals LoRa and then doing mode LoRa. But obviously if you want to customize it to your specific preference, then you should specify either your transmission power, spread factor, frequency, depending on how and where you're broadcasting from. Because obviously if you optimize it for your specific application, you'll be able to get better performance out of your transmissions. So I think that was everything really in terms of the raw LoRa stuff. So I'm happy to take questions if anyone wants to post them in the chat. I'll wait for a couple of minutes and take questions. Again, if you don't have your question answered today or you don't get a chance to reply, drop them in the forum and I'll roll them over to the next stream we do and take them from there. Also, feel free to comment with ideas for future streams, because that way I can gather information about what people want to hear and find out a little bit more about what people want to learn about. Okay. So I'll give it another minute for people to type up their questions, and if there aren't any more, then I will see you in 2 weeks when I do the stream again. Okay, so Todd, you're interested in the LoRaWAN and TTN Nano Gateway video. Yeah, that's definitely been an interesting one. And yeah, we'll give some suggestions on gateways as well. That's all good advice. The LoRaWAN TTN example should also get a write-up in the next week or so. I'm adding some more stuff to the documentation, which is an ongoing effort to push out everything that we can help you building your products with. So we'll get the video up for that and also try and time it to have the written example published as well. Regarding recommending gateways, so we had a multi-tech gateway in the office before that we were using for prototyping and testing with. This is currently on loan to one of our partners. I assume we're probably going to get the same version back in again, but that seemed to be quite an effective gateway. Did the job. We had it hooked up to TTN. It was doing its intended purpose. Didn't have much of a chance to try out the range on it. It would be interesting to do a write-up and see if we can get some real-world data as to performance of various gateways and get some feedback back. So maybe I'll do a open question to the forum and say if anyone's got their current gateways deployed, can they give some feedback and advice as to what their thoughts on their specific gateway is, and we can collate that and maybe put that into the documentation as well. So doesn't look like there are any other questions. So Todd, I will take your LoRaWAN and TTN suggestion, and we'll definitely do that next time the stream goes up. Yeah, inexpensive gateways. I don't think that that's an achievable option yet. The LoRaWAN gateways seem to be quite expensive at the moment, but hopefully, as time progresses, they'll decrease in price. fantastic. So look forward to taking questions in the forums and giving the next stream on LoRaWAN and TTN. So hopefully I will see some of you there again. And if you do have any questions, please drop them on the forums. Okay, I'll see you all in 2 weeks' time for the next stream.